Hello and welcome to another tutorial on dev.java website. We're looking at getting started with a Java application, and so far we've looked at how to set up your JDK, write your code, compile it, and eventually we want to run it. Running a Java application means basically just launching the JVM, and JVM is launches with the command Java. Java is a binary application that comes with the JDK. If you add the bin folder of your JDK to the path environment variable, then you can directly invoke Java without providing any absolute path or relative path, right? On the terminal, you just say Java, and the operating system realizes that this is not a absolute path or relative path, so it just goes and searches inside the folders that are appended to the path environment variable. If it can't find an application in the first folder that has the Java application inside of it just runs it, right? And we talked about the very important concept of class path, right? And the class path means actually before that, so since Java 11 they added this capability to run a single file Java application. What this means is that you don't even need to compile it, so you just launch the JVM Java and pass it the main the source file. And the key here is that this should be a single file application. What this means is that this class file shouldn't import anything that is imported by default. For example, it shouldn't import classes from other source files. Like, it should only import classes that are part of the standard Java libraries, which means anything that comes by default with JDK. We know that the Java base is automatically imported, or basically Java lang is automatically imported. The other classes come by default with the JDK, so you can import them and use them. And then basically what happens here is that behind the scenes the JVM first compiles this and saves the class file somewhere in the memory as a temporary file, and then loads that class in the memory, right? And then runs it, right? That's why when you do this, you have the restriction of not importing from other source files, then because then JVM has to be concerned with the class path, and here you cannot specify class path because it has to first compile this, right? So I'm going to create a new class, so single file application. Let's have a main method here, and then let's just do a sysout hello world, right? And we're going to also print something else to the console. This is a single file Java application, right? So we have this Java. We know that the Eclipse automatically compiles everything, and Eclipse compilation is very fast. If I look at my bin folder, as you can see, single file application class is already there, right? And I'm using a class decompiler to see what happens. We can also open this with the class file viewer to actually see the bytecodes, what are the instructions, right? Get a static, invoke virtual, etc. Or you can install a decompiler plugin for your Eclipse and then decompile it, and to see basically how the class file actually translates back into a source file, right? So this is the actual, for example, if you add comments and then you know that comments are not written to the class file. That's why when you add comments, so this is a comment. As soon as I hit save, Eclipse recompiles this class, this source file, and updates the class file. Now if I open this with a decompiler, you see the comment is gone, right? To show that it's actually recompiling, let's add some text here. As soon as I hit save, the class is recompiled and updated. So if I open this, you see this is updated, but the comment is not there, right? And we know that we can directly launch our application with Eclipse or from within your IDE, and this prints the result to the console that is provided here. Or we can, because this is a single file application, we can also, let's open a terminal right here, right? And let's clear this. Let's make sure that the JVM or the Java command can be found. Yes, I'm using JDK 15, and let's try to run this source file directly. And as you can see, it was run, and you see it took a little bit of time because when you hit this, it first compiles, right, and saves it as a temporary class file somewhere in the memory and loads that. So it maybe takes a little bit more time, but I can, for example, use any standard library that comes with the JDK. For example, with the math class, math sign of math.py, for example, or pi over 2 sysout a, right? Now I don't need to import math because math is part of the Java lang. So if I try to run this, it's going to still work fine, right? Let's try to do something that needs to import something. For example, let's save this variable a to file, right? Let's save this a to file. So what I'm going to do, I'm going to do a try with resources. Try, I'm going to write a file writer, f writer is a new file writer, and I'm going to give it a file, new file, and I'm going to give it a relative path from the working directory. And I know that when I launch with the Eclipse, the working directory is the source folder, so I want to put it in the source folder, test2.txt, right? So I already have a test.txt. I want to do a test2. Let's import file. And as you can see, now I'm importing two objects or two classes into my single file application, right? But these are part of the standard JDK. These are not my custom classes that I wrote. These are part of JDK. Now this throws exceptions. Let's catch the exception. That's fine. And we're going to say fwriter.write. We're going to write a, I guess, a string. And we're going to just say a. And this is going to complain because it expects a string, so we can just append it with, for example, a double quote. When you append with double quote, it calls the toString method on this and then add. So, and then we don't need to call the close. And remember, file writer is working with files. File means it's a resource of the operating system. So when we are done, the best practice is to always close the resource, because operating system will never allocate unlimited number of resources to an application. It doesn't matter if it's a Java application, C++ application, any application that eventually runs, operating system only allocates a limited amount of resources. Same with the stack memory, right? So same with the stack memory, operating system only adds, for example, I believe in Linux it's like 2 megabyte of stack memory. That's why you end up with a stack overflow. Now obviously JVM is a virtual machine, but and you don't worry about the stack, but a stack overflow can still happen. Same with resources, hardware resources. In this case is mainly file, or if you work with sockets, right, network communication, then sockets are also important. Sockets are used for network communication or inter-process communication. If you want to communicate with another application that is running through sockets, you can do that. But again, these are resources that operating system provides. Same with threads, I believe. Java threads map one-to-one to operating system threads. That's why threads are also precious resources, and you have to close them or dispose of them, etc. Now let's run this again, and it's compiling. It still works fine. If I refresh, let's see what happened. Where is this? Okay, so let's maybe let's run this to make sure that this works fine. We get this test2, we are writing that. What about, so the thing here is that with this, so where are we? We are in the let's refresh this. We are inside the PWD. We are in the text blocks. So we were actually here, right? And now we have this test2. So when we went, so the mistake that I made was that now when I'm launching from within Eclipse, what happens here is that the working directory, it's Eclipse sets it to, if you look at the run configuration, so I'm running this single file application, and in the arguments it's the project folder, workspace location, and then project folder, right? However, so if I launch this from Eclipse, this is a relative path, right? So if I don't specify anything, it means relative to the working directory of the JVM. If I say dot slash, it also means relative path, right? And then what happens is that, so if I launch this, so Eclipse sets the working directory for JVM. Remember, so we are launching JVM, which means we are launching an application, Java, and then the name of the file, right? Which means, and again, I've said it many times, that whenever you launch an application in your operating system, it is with respect to some working directory, right? Because your application might need to output some stuff to file, and it has to be able to provide, you should be able to provide not only absolute path, also relative path. So as you can see, it puts it in the source, in the project folder, right? That's because the working directory is set with respect to the project. But when I launch from terminal, things are different, because so right now, where am I? So I'm inside this package, text blocks, right? So when I say Java and then single file application Java, now it's with respect to the working directory is actually this folder, text blocks, right? So it's with respect to this. So if I have a relative file, so this is a relative, it creates the file and puts it inside the working directory, which is this folder. So if I run this, everything works fine. So a single source application still works fine. It's not importing any custom classes. And as you can see, this file was created and put here. So the conclusion here is that you have to be careful always when you're dealing with files or anything that requires paths. For example, a relative path or absolute path. Now, if you deal with absolute paths, you don't need to worry about this. For example, if I if I say, let's copy the absolute path of the project folder, right? And then say test2.txt. Now, this doesn't make, this works both. So basically, now this works regardless of what the working directory is when you launch your Java application. And I want you to really understand the concept of working directory, because when I started learning about files, this always confused me. Because your JVM is a Java application, right? So you're launching your Java application, your JVM, which means now JVM needs to have a working directory, because you have to launch the JVM as an application inside some working directory, right? So JVM has a working directory, and if you don't specify absolute paths for your files, then all the files are with respect to your the working directory of JVM, right? That's how it works. But now if I launch this again, now this is going to put it as the absolute path. So if I refresh this, as you can see now, the other one, test2, now it's here exactly as I was expecting that. If I remove this and tell the JVM this is a relative path, this is relative to the working directory of JVM, which if I launch it from within the text blocks package, right? Then it's going to put it inside the working directory, which is this folder, right? So I hope you really understand this concept to avoid any confusion in the future. All right. So the concept of working directory is very important. Single file application is a very nice thing to have, but normally Java programmers don't care really that much about this, because eventually we launch an IDE and launch our application from IDE, and we pretty much 100% of the time we have more than one class or Java source file, and we always import into each other. So single file application might not be very interesting to people who are already experienced with Java, right? And special IDs. Go further. So the first Java program showed you the basic steps every Java developer follows to run an application. Create a source file. The extension must be .java. We said that in other programming languages like C++ or C, there is no strict rule about the extension for the source files. You can actually tell the compiler to which files, which extensions are the compilation units. That's why in C++, you don't have the concept of source file. You have the concept of compilation unit, which means any file that you tell the compiler, any file that has this extension has to be compiled to an object file. Then the compiler goes in and compiles it. Now this obviously creates some complexity. That's why the Java developers decided to create some strict rules here. So the Java compiler only compiles files that have a .java extension. It never compiles any other file, and you cannot tell it to, hey, this kind of extension also is a Java source file. It doesn't do that, right? You don't have any way of telling Java C which files to compile. It only compiles .java files. Compile these files to produce a set of corresponding class binary files, and we discussed this. Even if you have multiple class definitions in a source file, each class definition must be compiled to a separate class file. That allows dynamic loading of classes, and JVM only loads classes if it needs them. Run them together as an application, right? Developers that work on large applications do not use plain text editors, and obviously this is what I've been saying many times. To manage their source code, they use integrated development environments. And I said the first rule of Java, playing the games with Java, is that you have to know your IDE before knowing your Java, right? IDE is the essential tool for statically typed languages like Java, C++, C, etc. IDEs are complex software applications specialized in software development. They manage a lot of stuff behind the scenes, so you don't need to worry about them. You only focus on writing good and clear code. And I'm going to repeat this again. The main job of a developer is to write good, clean code that is easily understood and easily maintainable. So maintainability of the code is very, very crucial if you plan to create a big project, large project. Now, if you have one or two source files, that's fine. I mean, you can kind of do a lousy job, but if you have hundreds of classes, hundreds of Java source codes, etc., hundreds of packages, you have to really think about how you're going to organize your code. And Java has been very popular for large applications, and there's a good reason for that, because obviously IDEs help a lot in managing. Java removes some of the complexities that are associated with building, for example, a C++ application. In C++, compilation and the build phase is kind of can be challenging at times, especially for very large projects, but Java is very simple, easy to use. And in these days, people might care less about the performance of the application because computers are already pretty fast, and they more care about the time to develop code, how easy it is to develop code, etc. These applications, IDEs, handle the compilation of your source code automatically. So as soon as you hit the save, this file is going to be compiled automatically behind the scenes. The other thing is linting, or showing you errors on the fly. So basically what happens here is that I made an intentional syntax error, and if you run Java C on this, it just prints the error to the console, but it doesn't really provide good visual cue about where the error is and how to solve it. And this even gives you suggestions what to do. It says change to print line. So that's it. So IDEs are very powerful in terms of not only finding the errors, potential errors, they also have good suggestions, and most of the time you just follow their suggestions, right? Because they've seen many codes. And these days there are also, for example, machine learning coding tools that come with IDEs, and they help a lot. They actually follow the style of your code and give suggestions based on the past codings that you've done. So these are very nice these tools are very nice. So they can help you track errors in the syntax of your Java code and nail down bugs in its execution, among other things, right? Now, for example, as I mentioned, you might change the name of a class, a source file, and then you might have imported it in 100 different classes. So IDE can quickly tell you where the errors are. As you can see, let's say I make an error here. Not only it tells me where the error is, it also shows me in the tree. It says in this project, in this source file, in this package, in this in this source file, there is an error, this red X. And this visual representation of the errors, especially in Eclipse IDE, is very nice. You can immediately see if you make a change and that breaks something, cause some syntax error, it immediately shows you where the errors are, and it has good suggestions. So I highly recommend you use an IDE like Eclipse or IntelliJ IDEA. These are very good IDEs. Some of these tools are open source and free to use. Eclipse Foundation maintains Eclipse. That's what I like to do. I'm a regular user of Eclipse. Apache Foundation maintains NetBeans. I believe NetBeans used to be maintained by Oracle, but then they moved to Apache Foundation. JetBrains publishes IntelliJ IDEA Community Edition. So CE Edition, Community Edition is completely free. Obviously, it doesn't have all the features of the commercial edition, but it is good enough that a lot of people are using that. That's free to use for personal and commercial development. And all right, so this was the whole introduction to this section of the dev.java, which was about getting started with Java. We covered a lot of topics. Next, we go deeper and deeper into the dev.java website. So if I go back to dev.java, we looked at the getting started with Java. Next, we look at the Java language basics. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.